Question number 1. Consider the crystal structure of KBr, which is modeled as a set of touching spheres. Each potassium atom has a radius R1 and each bromine atom has a radius R2. The centers of the spheres form a simple cubic lattice. The packing fraction of the system is, this is also a CSIR December 2014 question. Let's see how to solve. Here are 4 options given. Now these are different crystal structure: cubic, simple cubic. Second one is body centered cubic. Third one is face centered cubic. And atoms per unit cell is given. Relation between A and R is given. And the corresponding packing fraction is also given. Now how to solve this problem? In this problem, how to get it easily means just put R1 equal to R2 and check if you are getting pi by 6, because in the question it is given as KBr, potassium bromide. It is similar to NaCl structure, which is simple cubic, and the packing fraction should be pi by 6. Now let's take the first option, pi R1 equal to R2. So R1 equal to R2 means the first option, first term will be 1 by 2 cube plus again 1 by 2 cube, which will be equal to 1 by 8 plus 1 by 8, that is 1 by 4. So pi by 4, which is not the correct answer. Now let us check the second option, 2 pi by 3 R1 cube, that is 2 R cube divided by 2R times cube, so that is 2R whole cube. So 2 pi by 3 2R cube divided by 8R cube, R cube get cancelled, 1 by 4. So 2 pi by 3 times 1 by 4. So 1 9 to get cancelled, so you get pi by 6. So you have pi by 6, which is of KBr structure, which is the packing fraction. So option 2 is the correct one. You can also check with the option 3 and 4. Okay, 3 there is no pi, so let's leave that. Now but also you can check it. So 2R cube divided by 8R cube, so that will be equal to 1 by 4, which is equal to 0.25. Packing fraction in numerical value is around 0.5 for NaCl. So check for the fourth option. So pi times R1 cube plus R2 cube will give you 2R cube divided by 2 into R1 plus R2 is 2R, so 2R cube. So pi by 2 times 2R cube divided by 8R cube, 2 to get cancelled, so it will be pi by 8. So this is how you can check for the answers when you know the packing fraction for each of the crystal system. Now if you don't know the packing fraction for the crystal system, you can go for numerical method of solving. So now let's take the KBr which is similar to NaCl structure. The system has R1 and R2, the radius, and we have the side A. Now we are considering the entire crystal, not the unit cell. Okay, we are not considering unit cell because packing fraction will be constant. It's a amount of mass present, packing fraction, or volume present, so it doesn't matter. Sorry, not the mass, it's a volume of the sphere, volume of the material. Okay, so R1 and R2, we are considering A as the length of one side. Okay, so A by 2, that means the half of the length, will be covered by R1 and R2, which is nothing but 2 times R1, that is the diameter of the first sphere, plus 2 times the radius of the second, that is the diameter of the second one, will give you A. This we can write it as A equal to 2 times R1 plus R2. Okay, now in a system, how many formula units will be there is the question. Now we know that there will be 8 corners. 8 corners means the sphere has 8 corners. So 8 corners means 8 spheres, 8 sphere which will be filled by 4 K and another 4 by bromine. Okay, so 4 K and 4 bromine will be there in this 8 spheres. Okay, which means 4 kbr will be there. 4 kbr, that means it has 4 formula unit of ions. So let's calculate the volume of spheres. So for how many volume of K? 4 times 4 by 3 pi R1 cube plus 4 times 4 by 3 pi R2 cube, and here we can write it as 16 pi by 3 R1 cube plus R2 cube. Now let's see the volume of unit cell. Volume of the cell, so that is A cube. What is A? A already we know, it is 2 times R1 plus R2 cube. So that will be equal to 8 times R1 plus R2 cube. So packing fraction F is the volume of spheres divided by volume of the cell. So that will be equal to 16 pi by 3 R1 cube plus R2 cube divided by 8 R1 plus R2 cube, which is equal to 2 pi by 3 R1 cube plus R2 cube divided by R1 plus R2 You can join our WhatsApp group for the KSET classes. The link to the WhatsApp group will be given in the description box. And for the classes, we are starting the KSET 2026 classes. For the information about the classes or any queries, you can join the WhatsApp group.